Okay, hello, you're welcome to my channel. Now in this video, we want to find the antiderivative of this function. We have the function to be x over the square root of 4 minus x. Okay, so if you're new to my channel, you're welcome. This is Solo Anch, our channel on YouTube, alright? Okay, so if you're not subscribed to my channel yet, you do want to subscribe and turn on notifications. And if you like this video, you also share with your friends as well. Okay, great. So as we see the function, and now you notice that under the square root sign, we have a difference of two squares, right? Where this is just a number and this is an expression in terms of x. When these two are perfect squares, all right, or when you can make this number a perfect square and this right here is a perfect square, we usually start with a trigonometric substitution, and in particular, we say that x should be 2 sine theta. And the reason is because this 4 can be rewritten as 2 raised to the power 2. Okay, great. So let me start by that. Let's say let x be 2 sine theta. Alright, so given that means that dx, if we differentiate that with respect to theta, we're going to have 2 times the cosine of theta, and we can put the dx over here. Alright, great. So given that this is equal to sine theta, okay, from this equation, you can notice that if you divide both sides by 2, that means that sine theta will become x over 2. Alright, and that makes me curious a little bit, because I want to look at this on a right angle triangle, where this is the right angle and then this is the theta. If sine of an angle theta gives us x over 2, and you notice that sine is always opposite of a hypotenuse, that means opposite will be x and then the hypotenuse will be 2, x over 2, right? Okay, great. That tells us that the adjacent side to the angle using the Pythagoras rule will be the square of 2, which is going to be 4, minus the square of the other side, which is going to be x squared. Okay, great. So have taken note of all of those facts. This integral will become the integral of x, where x is just 2 sine theta, right? And then we say that divided by, well, the square root of 4 minus x squared. So that means we're going to have 4 minus x squared, where x is 2 sine theta. So x squared will be the square of this. That will be 4, then the square of sine theta, right? And then dx, well, dx from here is just 2 cosine theta d theta. So we have 2 cos theta d theta. Okay, very nice. So this will become the integral of, well, let's see what we can do up there. So this is 2 times 2 here. Maybe we can put the 4 out front. Then we have sine theta times the cosine of theta, right? So you just put the sine theta, then cos theta. Okay, great. Then this is divided by the square root of, okay, so you notice this. Well, this is 4 minus 4 sine theta. So you notice that 4 is common under that square root sign, right? So if you factor out 4, we are going to have 1 minus sine squared of theta. And if you take 4 out of this square root sign, it's going to become 2, right? Because the square root of 4 is just 2. So we're going to have 1 minus the square of sine theta left. And then over here, we just have the theta over there. Okay, very nice. So if you put this 2 out front, this is just 1/2, right? So we're going to have 2 here, because this 4 divided by 2 will give us 2. I put this as sine of theta times the cosine of theta. Divide this by, so you take note, 1 minus sine squared of theta is the square of cosine theta. And if you take the square root of the square of cosine theta, we're going to have just cosine theta left. So under here, we just have cosine theta, just from this square root notation. And we put the d theta over here. So you notice that cosine and cosine will cancel out nicely. And what we are left with is 2 times the antiderivative of sine theta d theta. So the antiderivative of sine theta is clearly equal to the negative of cosine of theta. So we multiply that by 2, that will be negative 2 times the cosine of theta. Okay, this is very nice. But then we need to get back to the original variable. So you take note that this is cosine of theta. Well, from this right angle triangle, cosine of theta is noted to be adjacent over hypotenuse. So that means we're going to have negative 2 times cosine theta is adjacent, which is this. That is the square root of 4 minus x squared divided by the hypotenuse, which is just 2, right? Okay, so you notice that this 2 and this 2 will cancel. That means we're going to be left with the negative of that. So let me just rewrite this as, okay, let's just put it over here real quick. So that means that this is going to become negative of the square root of 4 minus x squared. And since we are done, we can add an arbitrary constant, and this right here is the antiderivative of this function we're given. And if you'd like, you can put the c just in front before this negative term. Okay, that's very nice. So you see the step we followed, and I hope you get it. All right. Okay, please, thanks for watching. Please subscribe to my channel.